Hello everyone, welcome back to our class. We are now in our week 6, lesson 6, and today we are going to discuss about heat and temperature. Our most essential learning competency for this week, we are going to differentiate between heat and temperature at the molecular level. Our objective, we're going to differentiate heat and temperature. Heat transfer happens around us all the time. Although we do not see how this process actually takes place, its effects are evident. In fact, we rely on these effects every day in many of the activities that we do. Understanding the concepts behind heat transfer, therefore, help us do our activities more efficiently. You have learned in previous grades that heat transfer takes place between objects or places of different temperatures, and that heat transfer from an object of higher temperature to an object of lower temperature. You have also learned that heat can be transferred through conduction, convection, or radiation, and that heat transfer either through moving particles or electromagnetic waves. Lastly, you also learned about some factors that affect heat transfer, like conductivity of the materials. People often interchange the use of the terms heat and temperature in their daily conversations. They also think that heat and temperature are just the same. But for physicists, heat and temperature are two different concepts. So in this module, you will learn also the difference between heat and temperature. We define heat as transfer of thermal energy between objects or places due to temperature difference. Heat transfer from an object of higher temperature to an object of lower temperature. It is the quantity of energy absorbed or given off by an object. Heat is a form of energy and it is measured in joules. It takes about 4.2 joules of heat to change 1 gram of water by a Celsius degree. A unit of heat is still common in the United States, is the calorie. The device used to measure heat is the calorimeter. Temperature is the measure of hotness and coldness of an object. Temperature is measured in degrees and describes the average kinetic energy of molecules within a material or system. We use thermometer to measure temperature and it is measured in Celsius, Kelvin, Fahrenheit, or Rankine. It is measurable physical property of an object, also known as a state variable. Difference between heat and temperature. Heat deals with thermal energy, while temperature is more concerned on the molecular kinetic energy. Heat transfer of thermal energy between objects due to temperature differences. What is thermal energy? Energy contained within a system which is responsible for the temperature. It is produced when a rise in temperature causes atoms and molecules to move faster and collide with each other. The energy that comes from the temperature of the heated substance is called the thermal energy. Second law of thermodynamics. The second law of thermodynamics describes the relationship between thermal energy or heat and other forms of energy and how energy affects matter. The first law of thermodynamics states that energy cannot be created nor destroyed. The total quantity of energy in the universe stays the same. The second law of thermodynamics is about the quality of energy. It states that as energy is transferred or transformed, more and more of it is wasted. The second law also states that there is a natural tendency of any isolated system to degenerate into a more disordered state. The second law of thermodynamics states that heat will always flow spontaneously from hotter substances to colder ones. This simple statement explains why ice cube doesn't form outside on hot day or why it melts when dropped in a bowl of warm water. In a thought experiment, an ice cube dropped into a glass of warm water gained heat or thermal energy. From the glass, adding thermal energy leads to an increase in the kinetic energy of the ice molecules, and thus an increase in temperature. This is also because temperature is in fact the measure of average kinetic energy of the molecules. Furthermore, the ice will continue to gain thermal energy, causing its molecules to move faster and eventually their intermolecular bond or melt. In conclusion, the transfer of heat or thermal energy will typically change the temperature of the substance, but not always. For example, at the moment when the ice in the glass turns to water, those water molecules will be at the exact same temperature as when they were ice. In this case, instead of the thermal energy doing work to increase kinetic energy, it does work to break the intermolecular bonds, causing a change of state. However, as time goes on, the temperature of recently melted ice will increase until everything within the glass reaches equilibrium, meaning a consistent temperature throughout. Activity time! Let us have the activity entitled Dye and Water. Let us observe carefully what will happen as we pour dye in hot and cold water. Based on the observed experiment, the higher temperature of water, the faster the scattering of the dye. The particles are moving fastest in the container with hot water. The particles are moving slowest in the container with cold water. The higher the temperature of water, the greater the speed of the moving particles. The higher the temperature, the greater the kinetic energy of the particles. So in this activity, we can conclude that the greater the amount of heat transferred to an object, the greater the increase in the kinetic energy of the particles, and the greater the increase in the temperature of the object. And that's all for today. Thank you.